Hello, I'm John Nightingale, a director at JCT and the Symposium host. Now, the 25th JCT Traffic Signal Symposium was an online event this year, and I'm delighted to bring you a recording of one of the presentations. Now, these recordings would not have been possible without the support of a select group of our event partners. So our thanks go to the Institute of Highway Engineers, ITS UK, keepadistance.co.uk, Siemens Mobility, TWM, and of course, our media partner, Highways News. Please check out their short videos, which will tell you about some of the products and services that they can provide. Now, I hope you enjoy this presentation, and we would love to see you in person for our 25th anniversary event in Nottingham Trent University in September 2021. Hope you enjoy it. Thanks.
Thanks for the introduction, Paul. My name is Shailesh Mistry. I work for SWARCO Traffic Limited, and my colleague Paul Hudson is from Now Wireless. We're going to be discussing how we worked with Wolverhampton to improve, or looking into improving their air quality. So let's get this. So the original problem is air pollution. We have it in most of the major cities and everybody wants to do something about it. Wolverhampton contacted myself and Now Wireless and wanted us to look into the leading factors that cause the air pollution. Now, we have a lot of sensors within the city and it was all in remote places. So we were trying to bring the information all together into one place to be able to do something with that. My colleague Paul Hudson will now take over and show what they've done on their side.
Thanks, Shailesh. I'm going to have to sprint through these slides, I think like some kind of racing commentator. So here we go. For those that don't know, Now Wireless are a communications and sensor supplier. We were going since 1989, and I've been with the company for 20 years now. It's crazy. The main focus has been on saving councils ongoing revenue costs, which we've done in the hundreds of thousands over the last 15 years. 7 years ago, after a successful TfL trial looking at the link between journey time and pollution levels, we started to work on our own sensors, and in the last couple of years, we've deployed hundreds of Bluetooth detectors and pollution monitors across the UK. In time, we've been deploying our own focused AI software, looking at forecasting pollution levels, classifying county vehicles, and becoming a virtual loop detector. And as Shailesh has mentioned already, so Wolverhampton's main air quality issues are related to NO2 emissions from road traffic. Specifically, there are a number of hotspot areas where the annual mean air quality objective for NO2 was being exceeded. And we are now all becoming aware of the increase of ongoing health problems caused by overexposure to high levels of pollution, such as stroke, heart disease, lung cancer, and chronic respiratory diseases. And we all need to see what we can do to reduce those risks. Now, what Wolverhampton wanted to do was to get a clear picture of pollution levels in real time in these hotspot areas without having to spend tens of thousands of pounds on luminescent sensors. And as oh, I think that gone back a slide. There we go. And as part of the work as shown here, Wolverhampton have over 400 mesh nodes providing secure wireless comms to their on-street applications, such as the traffic light controllers. And using the mesh network, they're able to connect into it. The mesh network connects our pollution monitors and Bluetooth detectors directly into the devices, thus removing costs of communications and power installations to these sensors. They then want to be able to track the results and view them in real time, which they're able to do using our own SenseView software platform, and then to import the data into SWARCO's MyCity to be able to look at how best to use this data. So this shows the components that Wolverhampton used in the project. The intelligent antenna and mesh node here show on the right, provide the power communications to the sensors, here shown on the left. The NO2 detector takes readings from the gas sensors every 60 seconds, recording the data to a database. If it detects a peak above a preset value, then it can send an alert via email or text and can write to a URL with a data update, and that can be sent directly to the OTU via a simple web page. The Bluetooth detector seen here can be used to track traffic as it passes through the city, and then we can track to see how pollution levels are affected as journey time increases or decreases. The CCTV and video analytics shown here can be used to classify vehicles. Heavy-duty vehicles can produce twice as much NO2 as cars, and idling engines can also cause spikes of NO2, and all of which can be spotted using our AI. The image in the middle shows our in-house UI, which shows the levels of NO2 at specific sites where the NO2 detection is installed and journey times for set routes in real time. This gives a clear picture of what is happening on street. And as the data is recorded, we can also look at historic journey times and pollution levels, track improvements or not, as we implement plans which we hope will reduce NO2 and improve air quality. The data here shows an overview of the pollution as a whole over the whole of Wolverhampton, with a more detailed look in a minute at specific pollution site and journey times. You can see here the beginning of lockdown, you can see a significant drop in pollution, which is also highlighted here on this individual site. And then we can also see through journey time, the journeys themselves. So the actual number of journeys, which is the dotted line, you can see a significant drop there as lockdown occurred. Okay, so I've already spoken about the analysis of the data. It's good to point out that analysis doesn't stop while plans are put in place. It's equally, if not more so, important to track the changes of anything we do. I'm sure that some of the plans we put in place may seem intuitive to us. However, we need to make sure that changes improve the air quality and not worsen it. During the first phase of integration, only a few of the detection devices were integrated into MyCity. This included the 5 pollution sensors, 72 Bluetooth detectors, 28 vehicle counters. The feed data was sampled every 5 minutes, which resulted in roughly 30,000 data points collected each day. And the second phase of integration will bring in the rest, giving a total of 200 detection devices, resulting in 60,000 data points per day, and an overall of 22 million data points per year. That's a lot of data. The initial actions will be to look at changing traffic plans, so timings, etc. Look at gating traffic outside the areas of concern, so the hotspot areas. We'd also look to try and change driver behaviour and mindset by informing the drivers of the quickest routes available, or by informing drivers of pollution levels in certain areas, so school environments, drop-off points near schools, things like this. And we would also look to inform drivers of the best time to travel by informing the drivers of the lowest journey times in the day, so that if people can wait and be productive at home, the journey later will be quicker, and therefore the lost time travelling will be reduced. So the future, well, I've already talked about the next phase of integration with SWARCO, importing more data from more sensors. We will continue to develop our AI software, and since writing this presentation, we're already implementing cycle and pedestrian counting. More sensors does present problems in how we manage all the data generated. However, more data gives us a clearer picture as to what is happening on the street, what changes we need to make, and how successful those changes are. Among those next steps, we'll be implementing our pollution forecasting, so we can be proactive to high pollution levels rather than reactive. The graph here shows us forecasting NO2 an hour ahead, and then an hour later recording the actual NO2 levels there in blue. Now, hopefully our plans would show lower forecasts and then actual lower NO2 levels. And finally, improving air quality for all should ensure a safer and quicker commute to work, a safer drop-off at school for our children, and a safer and healthier place to live. Right, I'll now pass back to Shailesh for the rest of the presentation. Thank you.
So, what does the actual architecture look like? Reiterating from what Paul said, we have a number of pollution sensors, journey time sensors, vehicle counters, and they all feed in to the Now Wireless cloud. From there, we take the JSON feed and we feed it into MyCity. So it's fairly straightforward. The more devices that the customer wants to bring online, they will feed straight into the cloud, and we will take that feed straight off. Again, we have to note that we are taking readings every 5 minutes, so that's roughly 30,000 data points per day. And in the next phase, we are looking to double that, so that's 60,000 data points per day, or reaching a 22 million data point per year. And that's a lot of information that needs processing, and we need to figure out what we can physically do with that. Now, this is the pollution data as it's shown within MyCity. We have similar feeds that show the journey time and the vehicle count. This is just an illustration, and the other ones will look fairly similar. So I'll just talk about the pollution data. You can see from the map that we've got these lovely icons that are color-coded. So during normal pollution levels, they will be green. At low pollution levels, they turn yellow, and at high pollution levels, they turn red. You can hover over them and you get some basic information about the actual values that are showing at the moment. This is known as the map view, and it's fairly straightforward and basic information. Some people want to know more. So we have the list view where you can have all your devices. You can see all the different pollution levels. You can see the actual values. And there's quite a few columns off here to the right, but it's one of those customizable views. So you can show as much or as little information as you want to. And then the final way of representing data is called the chart view. So here we have real data from a particular day. Now, don't worry, the pollution levels weren't actually that high during that day, but these are customizable levels that you can set so that you can see at a glance whether you're going above or below the low and the high warning levels. So the challenges that we actually faced, it was actually to do with data storage and retrieval. We were having a huge demand for data and actually trying to access the data in a form that the user could use. So we've got ease of access. I mean, we are talking just for one device for a week, that is 2,000 data points. We also realized that formatting of the results is very important. Different people want to see the information in different ways. We have the customizable aspect of this in that they want to have different reports on a daily, weekly, or a yearly basis. And all this information is usually used for either internal or external reporting. So internally, we're looking at higher management functionality, and externally, we're looking at actually showing the information to the public and letting them either view what the levels are within the city or actually being able to physically do something with them. So looking ahead, what do we have to do next for Wolverhampton? We definitely have to think about data warehousing. We have so much information and we have to be able to store it and be able to make it accessible to the public and to the user. We're also trying to look into bringing complementary data feeds. So I have listed weather and planned and unplanned events. We can bring in things like a Datex feed. I mean, it's whatever the feed you have, we can bring it in. It just has to be in a very good, clean format. And of course, looking ahead, we need to think about the strategy manager. So Wolverhampton would like the option to either look at individual data points or collated data points and make decisions based on those. They would like to update their VMSs and their real-time passenger information systems so that customers can know instantly what's going on and how to avoid high pollution areas. Again, with help of Paul, we're looking at forecasting and trying to plan ahead and saying, right, we know what's going to happen within the next hour, so we should redirect track if it's possible. And with a view to that, we're looking at traffic plan changes and either automating or semi-automating those. So what does the actual final solution look like? This is MyCity. It's based on all the technologies that we have at SWARCO throughout the world. So if you think about parking guidance and pollution management and all the other functionality that you would like to have, it exists in different places in different formats. And MyCity is bringing all of those functionalities into the one platform from all the other cities that it's available for use. So in the top left here, we can see monitoring. That's where Wolverhampton are right now. They are trying to bring in all of their data sources that they can. Later on, we'd be looking at automating, which is trying to make either scheduled or semi-automatic changes. We have control of VMSs here on the left. Data analytics is definitely coming into play later on, where we will be looking at different ways to control the traffic or to monitor the different pollution levels that we have, especially in terms of bus priorities and pedestrians. And later on, we're hoping to get into the connect phase. I mean, the technology already exists for us. It's just bringing it into MyCity. And here we have vehicle-to-vehicle communications and vehicle-to-infrastructure. So exciting times ahead, and it's purely trying to figure out what the root causes are and what we can do to control them for Wolverhampton. Thank you for your time. That was our talk.